Let's take a look at the nuclear fission PhET. So we're going to run the sim. This is another old Java applet. So this is uranium-235. This little gun here will shoot neutrons, right? Not too fast though, right? Because if you shoot a neutron too fast, it can go through this without sticking to it. So let's fire a neutron at it and watch what happens. Ooh. So reset it. What I want you to notice is watch the energy level here, right? So right now it's stable. Now it's energetic enough. Boom, it splits. Do you see the extra neutrons that fly off? That's because the pieces that it makes can't bind that many neutrons, right? The farther you go toward, the larger masses, the more neutrons to protons you have. And so if you break into smaller things, you're going to have extra neutrons that can't remain bound. And of course, those are the things that start the chain reaction, right? So now we want to do the chain reaction. So click at the top, right? That's the fun part. Slide this, put the slider to 100 nuclei. To 100 nuclei. Fire the neutron gun. If it misses all the nuclei, you can aim the gun by dragging the muzzle of it. It's not going to miss. Watch. Here's the chain reaction. You see all that energy. Sometimes there's like somebody left, right? You can fire it. Ooh. Every now and then one of them survives. That guy might survive. There you go, right? Okay. We did that just for fun, didn't we? We noticed that the released neutrons from the fission reaction all set off subsequent reactions. This is what we mean by a chain reaction. Do it a few times. Notice that every now and then there's a nucleus that doesn't get nailed by a neutron. Now reset the nuclear and drag this slider to 50 and set it off again. So let's put this to 50. Let's set it off. And those all destroyed, right? Okay, let's try 25. Right, and there's something, right? Try only 10, right? You can aim the gun. It's hard to get a chain reaction the fewer you have. So this is the concept, you're sort of developing the concept of critical mass, right? You have to have enough so that the neutrons have a good chance of starting another another reaction, right? Let's see, end up with fewer than half, right? And there's right about 25 nuclei. There seems to be something going on, right? So that's critical mass. And now let's look at not pure, right? So let's go 50 uranium-235. And 50 uranium-238. Let's try it. Let's see what it does. We got to aim it at one of these guys. So it's not quite as crazy, right? If it's half 235, 238 is not fissile, right? So the uranium-238 absorbs the neutrons without releasing any. They're kind of a damper. So keep the uranium-238 at 50 and mess with the number of uranium-235 nuclei. So between 50 and 60, there's a transition of efficiency there, right? And then let's go look at the nuclear reactor. Okay, notice that there are now nuclei with fuel rods. So here are the inside the fuel rods here, right? This is the control rod, right? To absorb neutron. Drag the control rods out all the way down. You were going to do it anyway. Click the red fire neutrons button. And watch it go Chernobyl on you. It didn't go Chernobyl. How come? Oh, there we go. It did. It is going. Actually, Chernobyl was just a conventional fire, right? I mean, it was lit by nuclear, but it was burning. All right. A real reactor would get so hot the fuel would melt together. Do an image search for elephant's foot Chernobyl, and you'll get a picture of some poor dead person kneeling next to the melted fuel. What's missing from this sim is the notion that the released neutrons all interact. In a real reactor, we'd have to slow the neutrons down to get them to stick to the nucleus. Fast neutrons just go through the nucleus without sticking. Most reactors use water as a moderator, but the reactor at Chernobyl used graphite, which can burn if you get it hot enough. Try a few positions of the control rods to see that we control reactions that way. All right, so let's reset this. Let's try this. Put it there. Let's fire the neutrons. That might be too much control. Anyway, you can mess with where the control rods are, and you can see the energy produced and anyway. I don't know. I think it's kind of cool.